Hey there, and welcome. When we think about history, we usually think in these grand terms, like huge eras or big pivotal years. But what if I told you that you could unlock a massive story just by zooming in on a single, ordinary day? Well, that's what we're going to do today. We're unlocking March 1st.
Yeah, I know. It sounds like the beginning of a really weird joke, right? An atomic spy, an aviation pioneer, and a bad guess about math walk into a bar. But seriously, there is a real thread that ties these completely different worlds together. So what on earth could it be?
Well, the answer is surprisingly simple. It's just the date. And well, yeah, other big things happened on this day, like the trial of atomic spy Klaus Fuchs. We're going to use it to unlock the secret history of a totally different field, mathematics. All right, let's really get into it. We're going to see how, just by looking at the birthdays and death days of some incredible thinkers, all on this one day, March 1st, we can actually see an amazing picture of how math itself has grown and changed over time. So our story kicks off in the 19th century. We're going to look at two men who both happened to die on March 1st. And these two guys could not have been more different. But together, they built the practical, real-world foundations that so much of modern math would stand on. So first up is Peter Barlow. And this quote is just fantastic. I mean, it is hands down one of the all-time greatest wrong predictions in the history of math. He was just so sure, so positive, that no one would ever find a bigger perfect number. And of course, we've found a whole bunch of them since. It's just a great reminder that even the most brilliant people can be completely spectacularly wrong. But hey, predictions weren't his real legacy. His true gift to the world was just pure, relentless hard work. This number, 10,000, that represents the absolutely monumental effort of his most famous book. In it, he calculated the squares, the cubes, the roots, and the factors for every single whole number from 1 all the way to 10,000. I want you to try and imagine a world with no calculators, not even a basic one. That's the world Barlow lived in. And his tables, they were basically the engine that powered the 19th century. If you are building a bridge, designing a machine, or even just doing your science homework, you had Barlow's tables right by your side. It was absolutely indispensable. And this, right here, just perfectly illustrates the two sides of math back then. On the very same day, March 1st, just 22 years apart, we lost two key figures. In 1862, you had Barlow, the self-taught, hands-on engineer. Then, in 1884, Isaac Todhunter, the Cambridge scholar. One guy was out there building tools for the real world, and the other was locked away, building minds with his super popular textbooks, living this reclusive life in what one of his students called a perfect atmosphere of mathematics. Okay, so we've laid the groundwork, literally. Now let's take to the skies. Because on this very same day, March 1st, a man was born whose theoretical brilliance was absolutely critical for getting humanity off the ground. So let me introduce you to George Bryan, and this guy's backstory is totally unconventional. He was considered too fragile for regular school, so he was educated entirely at home and during trips around Europe. And maybe, just maybe, that unique childhood is what helped him develop a mind that could see the world in a totally new way. Okay, so what was his big idea? It all comes down to this concept right here, dynamical stability. See, before Bryan, people were trying to build flying machines, right? But they didn't have the math to figure out why they were so darn unstable. Bryan was the one who came up with the equations that could actually describe how an airplane could fly straight and, crucially, how it could recover from things like a gust of wind. I mean, this guy's work ethic was just off the charts. It's like he was living two separate careers at the exact same time. In one, he's doing this absolutely groundbreaking research into flight and thermodynamics. And in the other, he's just cranking out more than 20 super popular textbooks for college students. It's incredible. But that kind of incredible output, it came at a price. The sheer pressure of all his research, his writing, his teaching at the University of Bangor, it just became too much, and he ended up having a nervous breakdown. It's such a powerful reminder of the very real human sacrifice that's often behind these massive scientific leaps. And just look at the timing here. It's perfect. The Wright brothers make their first flight in 1903, the English Channel gets crossed by a plane in 1909, and then, just 2 years later, bam, Bryan publishes his masterpiece, Stability in Aviation. His theory was the mathematical bedrock, the foundation that made all the rapid, world-changing advances in flight possible. Okay, time to shift gears completely. We've been talking about tangible stuff, right? Tables, airplanes. Now we're heading into the world of pure thought. March 1st also introduces us to the mathematicians who built entire universes inside their own minds, the pioneers of abstract algebra. This quote here from Paul Dubreil, who, you guessed it, was born on March 1st, 1904, it's just perfect. He was apparently totally stuck on his PhD work, and then his friend, the legendary Andre Weil, told him he had to check out the revolutionary new ideas from Emmy Noether. And it just lit a fire under him, completely changed everything. It's such a great reminder that math isn't just one person in a room. It's a conversation, a collaboration between brilliant people. And Dubreil wasn't alone. He was part of this bigger wave. March 1st connects us to this whole generation of abstract architects. You've got Heinrich Muschke, who helps turn the University of Chicago into a math powerhouse here in America. You've got Dubreil, of course. And then there's Gustave Choquet, whose ideas were so foundational that everyone who came after him just named the field after him, Choquet theory. These guys were mapping out totally new universes of thought. So let's take a breath. After that whirlwind tour through the centuries, what has this one single day actually revealed to us? What's the takeaway? I mean, think about the cast of characters we've met, all connected by this one random day. We've got the practical engineer, the foundational educator, the visionary flight pioneer, and the deep-thinking abstract theorists. Each one played a totally different but vital role in the story. And that, right there, is the whole point. This single day, March 1st, is like a perfect little snapshot, a microcosm of the entire history of mathematics. It shows us the evolution from solving concrete problems with physical tools all the way to the soaring theories of flight and the deepest, most abstract ideas you can imagine. It really makes you think, doesn't it? If this much history, this much human drama and genius is packed into just one day, what other stories are just sitting there, waiting for us in the rest of the calendar? It just goes to show you, history isn't something that's locked away in dusty books. It's all around us, waiting to be discovered, one day at a time.